Hello everyone. In this video, we will be presenting our first iteration of our real-time internet monitor called INTERMETER, which is part of our MDP project. We ran the code in Jupyter Notebook on Google Colab. First, we started by importing the required libraries like pandas, numpy, matplotlib, and requests to call RipeStats API and fetch the needed information to be put in a dataset. We collected information from the API in JSON format, then transformed it into a pandas data frame. The data is available in real time, so we do not have an already present dataset. It is imported while running the code. Start time is turned into an interpretable format of year, month, day, and made it the index. We plotted the data that was taken from the API and that represents the announcements. We can see that we have some peaks corresponding to a high number of announcements, which is a sign of instability.
In this second section, we redefined another dataset that only included the start time and the announcements. The rest of the features were dropped. We imported Keras models and the layers to begin our training and testing, using the LSTM method. With min-max scaler, we normalized the given values between 0 and 1 for better outputs. We then divided the data for training and testing. After that, we applied fit transform on our new dataset to obtain the scaled data and split them between X and Y train. We then initialized our neural network made of 32 layers and using the rectified linear unit activation method.
We then compiled our model, which ties it to the TensorFlow backend with the Adam optimizer, and the mean absolute percentage error matrix was used. Right after, we fit the model with 500 epochs, representing the number of passes the entire training dataset completed and a batch size of 8. As we can see here, the training was done. The testing data was then filled to be tested and gave us the predicted results. We applied the predict method to our model to collect the predicted state. In the end, we plotted the predicted and actual data right here. So the predicted and the actual data to see how accurate our results were. So here we can see a difference in the plot because different scaling was used on the x-axis, but the results are very similar. We had a loss of 0.19%, which is considerably a great prediction. Thank you for watching and see you in our next iteration.